Is the voice okay? Okay, sir. Let's start. A very good morning, students. In the very previous lecture, we have just started with our chapter number first, that is the solid state. The solid state, we have had a brief introduction and we have introduced the main topic, that was the crystal lattice and the unit cell. So I'll just revise the unit cell and its properties so that we will connect with the today's topic and then we will start. Okay. So the unit cell and the crystal lattice, it was basically defined as the unit cell is the smallest portion of a crystal lattice, which over and over again and again when repeated, it would get you the whole crystal lattice. And crystal lattice, it is nothing, it is just a three-dimensional form of a solid. Okay, just to visualize it, just to have more information about it, we have given it a name, that is the crystal lattice. Okay, now we will start with our today's topic with the what are the unit cell and what are its properties and what are the different types. See, we have already studied that in our unit cell there are two things were quite important. First one was the edge length and the second one the angles, that is alpha, beta, gamma, and the edge length were A, B, and C. Since we are talking in three dimension and we know very well that our solids are in three dimension, they have they have the properties like they have the height also, they have the length also, they have the breadth also. So that's why we have given them the name that they have the edge length A, B, and C, and the angles alpha, beta, and gamma. Okay. Rather than that, we have also studied that we have made a three-dimensional representation like this of unit cell, and each dot at each corner represent its constituent. It could be atom, molecule, or ion. This whole concept was clear, and I hope you have revised this very well. Now we are going to move on our next topic, that is known as the different types of unit cells. Okay, let's start. See, we have discussed that there are different type of unit cells and they can vary on the basis of edge length as well as alpha, beta, gamma. Okay, rather than that, we have different type of unit cells on the basis of number of atoms present in the corner, present in the unit cell. Okay, so let's start. The first one is known as simple or primitive unit cell. Basically, we have three type of unit cell, that is simple or primitive, body centered, and face centered. Lastly, we have end centered too, but that's not so much important and not so much discussed. We will not study much about that particular topic. Okay. Now let's start with our first topic, that is the simple or primitive unit cell. See, as I have already told you that the corners dot represent the number of constituent atoms or molecules. So the simple, as the name suggests, or the primitive unit cell means the unit cell containing the number of atoms present only at the corners. So we have just the atoms present at all the corners. And how many number of points we have actually? 1, 2, 3, 4, 5, 6, 7, 8. Total number of 8 atoms present over. Okay. Now we are going to it seems to be that there are 8 number of atoms present in this unit cell. Now we are going to our higher topic, that is body centered unit cell and face centered unit cell. See, it depends upon the structure of solid, like we are having graphite, we are having zinc sulfide, we are having sodium chloride. All the solids have different type of structures. Their unit cell must have different type of structures. So the unit cell, the atoms are not only present in the corner like this way, they are at corner as well as the center of the unit cell. It could be any kind of center. It could be in the center of body. It could be center at the center of any face of unit cell. Okay, so let's start. Now, let's start with body-centered unit cell. See, as the diagram suggests us and as the name suggests us, body-centered unit cell means we have all the 8, we are seeing all the atoms at the corners, and also there is an atom present in the center of the body of the unit cell. That means in a whole three-dimensional cubic structure, we have another atom that is present in the center of our body of the unit cell. Okay, this one is most important and second type. Third, we are having face-centered unit cell. Now, what does mean by face-centered? See, as the three-dimensional diagram have already made you some sense, make some idea that we have total 6 faces. 1, 2, 3, 4, fifth one at the upper and the sixth one at the lower. Okay, it's the 3 dimensions, so please try to imagine. In a 3-dimension box, in 3-dimension cube, we have total 6 faces. Okay, so in each face, we have one atom present over there. So let's this one atom represents at the upper face, this one represents at the lower face, this one at the right hand side, left hand side, and this one at the right hand side. 4 faces are covered, first one at the upper and the last one at the lower. Okay, this seems to be a little bit complex, but this is very simple because it's a 3-dimensional representation, and in your lower classes you have already heard about cuboid in the 9th class, in the 10th class in mathematics. Okay, even since from 7th class in mathematics. Okay, so just try to relate with that topic, that in the solid state we are going to study them but in 3 dimensions. Okay, so in short, we have 3 type of unit cell. Most importantly, the simple or primitive, that means atoms are present only at the corners. Body center, that means atoms are present at the corners, as well as one atom is present at the center of the whole body of the atom. All right, now we're going to move with our third topic, that is face center. That means at the corner of the atoms are present at the corner of unit cell, as well as the center of each phase of the unit cell. That means at the center of total 6 faces of unit cell. All right. In spite of that, we have also end-centered unit cell, but that's not so important. End-centered, I'll just give the definition. End-centered means the atoms are present at the corners as well as they are present at the end faces, at the center of end faces. Like only the upper one and the lower one, they have only one. Like at the end, they have only one. So if I'm talking about this one and this one, they have only one. From this one and this one, they have only one. And from this one and this one, they have only one. So only 3. Okay, but that's not in your syllabus and we will not discuss this. Okay, these all 3 were our most important topic of unit cell and type of unit cell, which can be classified only on the presence of number of atoms, where are they present. Okay, so this was all about this topic. Now let's move to our next topic, that is different type of unit cells on the basis of their axial angles as well as their edge length. Okay, see students, I have already told you that we have so many different type of unit cells on the basis of edge length, on the basis of their angles, as well as on the basis of atoms. These are the basics unit cell. Okay, now we are having the primitive unit cell and its classification. Okay, so there are total 7 types of primitive unit cells. If we are going to face centered through and body centered through, they can also have the different type of edge length and different type of angles and different type of examples, but that would be too broad. That would be so much complex, because that would be you can say so much work to remember. Okay, because this seems to be almost, we can say, a theoretical concept. Okay, So we will avoid them. We will just focus on the simple or primitive unit cell. I'm not saying that there are no possibilities of these two. There are so many possibilities, but more that are more vast and complex. So we'll leave this. We will just focus on the primitive unit cell. That is, we're having number of atoms present only at the corner rather than the face of the body, or sorry, rather than the center of the face or the center of our body. Okay, so let's start. I hope this topic has made sense to you. Now move to our next topic, the 7 different types of unit cells. Okay, we have 7 primitive unit cells on the basis of edge length. I have already told about the edge length, the height, the breadth, the length, the ABC, and the axial angles. Why I'm saying axials? Because they are meeting at the axis. These are alpha, beta, and gamma. Okay, let's start. Now, we have to remember these all 7 primitive unit cell with their name as well as their edge length as well as their angles. Okay, and that seems to be a little complex, so I have made a short trick. I hope you guys go through it, and if you're having fun with it, if you're liking this, then just go with it. If you don't like it, then just have somewhere else. Okay, so I have just remembered it with cute our mother. I have remembered this with cute our mother. Okay, we have total 7 types, that is cubic, tetragonal, orthorhombic, rhombic, monoclinic, and this is octahedral, tetrahedral, hexagonal, and rhombus. Okay, so these 7 are our simple primitive unit cell. So let's start. I'm just going to write in the form of table. Okay, let me just write this one. First one is cubic, the name of primitive unit cell, the edge length, the axial angle, and the last one would be examples. Okay, so let's start with the first one, that is cubic. Second one is our tetragonal. Next one is our orthorhombic. Next one is our monoclinic. Next one is triclinic. Next one is hexagonal. And the last one is, I think, rhombo. Yes, rhombohedral. So these all are 7 types of unit alpha, beta, and gamma. So let's start. See, so many concepts. So I have made them as A equals to B equals to C, and in the last one, A equals to B equals to C. That means both cubic and rhombohedral have all the three edge length equal to each other. Okay, now the second one, A equal to B not equal to C. The second last one, A equal to B not equal to C. Okay, and we are left with only three, then just they all are not equal. Okay, what I have done, first and last same, second and second last same, and all three are not equal having edge length. Now start with axial angle. Alpha beta equals to gamma equals to 90 degree, same as it is. Yes, the three have the same alpha beta gamma equals to 90 degree. And the last one have alpha beta equals to gamma, but not equals to 90 degree. Okay, now we are left with three, the monoclinic, the triclinic, and the hexagonal. Let's start with monoclinic, which have alpha equals to gamma equals to 90 degree, but beta not equals to 90 degree. Let's start with hexagonal. Alpha equals to the beta equals to 90 degree and gamma equals to 120 degree since it is hexagonal. In hexagonal, there must be an angle should be of 120 degree, and we are left with only the triclinic. So these triclinic is which has no edge length equal, no angle equal to 90 degree, and no angle are equal to each other too. C class, this seems to be a trick, and yes, this is a trick which I have tried to remember, and either in competitive exam, if you're going to focus on going through your book, it has just written in different ways, and you will keep memorizing it, you will keep working. Triclinic is the only one which has nothing equal to it. Okay, so this was all about the 7 types of primitive unit cell, which is very important. This table is very important in any kind of exam, in your board exam, in your computer exam, any kind of exam. Okay, so please for example, cubic, we have sodium chloride solution. It's not solution, sodium chloride salt. If I'm having about tetragonal, this is example of tin oxide. Let me write. Observe that after some time, whenever we take a glass and we put into windows of our buildings, the glass after some time starts becoming thicker at the lower side, whereas the at the upper side is thinner. That's the reason that the glass is flowing. It seems little absurd, but this is true that the glass is actually flowing with the time. So this is not the property of solid actually. That's why we call amorphous solid the pseudo solid. That means the false solid. Am I clear, bache?
Yes.
Discussed the primitive unit cell and its types on the basis of our edge length as well as the axial angle. And I was just giving some examples to you. That, for example, sodium chloride, it has all the sides and all the angles equal. That means it's the most simplest way to represent a solid. Okay. Next, we're having SnO2, that is tin oxide. This represents our tetragonal structure. The sulfur, that means the polyform of sulfur. When I'm talking about sulfur, it doesn't mean that only a molecule of sulfur is over there. Sulfur always contain in 8 or 16 atoms. That means S8 or S16. Okay. Same as it is when we are going to move with orthorhombic, it is example of bisulfate. Same as it is, the monoclinic represents the sodium sulfate with 10 moles of water. Hexagonal represents, and the last one we have left with triclinic, that is potassium dichromate. So as we keep moving with our solid state, or as we keep moving with the chemistry in the details, like we are going to move with coordination chemistry, where we will discuss with potassium dichromate, we will come to know about these structures. Okay, but now, for right now, you have to keep in your mind this particular table, and this would come definitely 110% for 2 to 3 marks in your board exam too, that you would be given any kind of name and you have to represent the edge length as well as the axial. Okay, so sir, how much time we are left with? 10 minutes. Okay, so let's start with another topic too. We will cover that's very short topic, and then we will finish the class.
Ma'am, left with the only 4 to 5 minutes, ma'am. 5 to 6 minutes.
4 to 5 minutes. Okay,
yes, ma'am. You can continue.
Okay, class. Okay, class. So let's start with a last simple topic. Number of atoms in unit cells. Okay, if I'm talking about number of atoms in unit cells, that's a vast topic, but I'll just give you a brief idea. We have 3 different type of unit cells. We have just discussed the body center, the phase center, and the simple units. Okay, in each unit cell, we have discussed that there are number of atoms present in the corner as well as the center. On the basis of this, plus on the basis of 3-dimensional representation, is not only present